Okay, so let's proceed to the application on centroid of plane areas. So since we are now done with determining the area in both rectangular and polar coordinates, so we go back to the rectangular coordinates of solving the plane area, and for that particular area is that we're going to solve the centroid. Alright, so most likely this topic will be relevant once you reach your mechanics 1 or statics of rigid bodies, because you'll be determining the centroids of different materials such as your steel plate, so on and so forth. So this topic is essential in your design subjects. So especially when you reach reinforced concrete, so this particular topic will go back again once you are going to solve for centroids of materials. Okay, so we know that the Earth exerts a gravitational force, and usually it is applied at the center of gravity of the body. So the centroid of an area is analogous to the center of gravity of a body. So, so most likely they are just the same. So the the concept of solving the centroid of an area is the same as the concept of solving the center of gravity of a body. So the concept of the first moment of an area is used to locate the centroid. So if you're going to locate the center of gravity of a body, so most likely you're going to use the physics formula. But for solving the centroid of an area, so we're going to use Varignon's theorem. So more likely um, the same as the moment equation. So I think you don't have yet the moment equation at your level, but once you reach again statics of rigid bodies, so the moment formula will be introduced in that course or subject. Okay, so most likely if we're going to use physics, so again, since we are not dealing with area, we are dealing with weight. So if you try to derive your figure, is that the left side, this one, the left side, as you can see the coordinates, you're going to have bar x and bar y, so that will be the direction going towards the center of gravity of a plate, is equal, so notice the equal sign here, is equal to the summation. So as you can see also on the formula below, so the left side is this one, so meaning bar x times the total weight is equal to the summation of the weight components, so meaning you're going to add up the different weight um, weight locations and its corresponding center of gravity. So if I'm going to say it in layman's terms, so it's more like a you're adding up pieces of the whole body with their respective center of mass. So for example, I'm going to add up the mass of my hand, and then the corresponding centroid of my hand plus the weight of my head, and then the corresponding centroid of my head plus my body, so on and so forth. And when I add them up, it is just equal to my centroid plus times the total weight. So that's more likely the idea. So if we so in so in area so in area concept, so for example, you're going to have an irregular shape figure, so let's say we're going to have this L-shaped figure. So for you to better understand the formula, so for example, the centroid is at this location. So let's say bar x, bar y, and this is the total area. So the right hand side of the equation is stating that since it's the summation of the components, so more likely we can say that, let's say you're going to divide this one into two areas. So this one is area 1, then area 2, and then this is the corresponding centroid of the two areas. So you're going to add these up, and then it is just equal to the whole system. So marag mo na siya ang idea. So the left side is the whole component, the right side is the individual components adding up into the whole component. Okay, so the centroid must lie on any line of symmetry of the homogeneous figure. So take note that we're going to be dealing with homogeneous figure only, meaning the material is homogeneous. But in our case, since we are just solving for the area, not the weight, or let's say the center of mass, so most likely we can just ignore this one. So homogeneous figure. So this particular line is stating that your material should be total steel, total bronze, because if you're going to have a non-homogeneous figure, so that will create another type of solution for you to determine the center of gravity. Okay, so the geometrical center of the figure is the centroid. And again, this is what I'm talking about earlier. So if a figure A, and then, so let's say the figure A, that's the total area, and it consists of several parts. So meaning you can create different parts of that figure. So let's say you can isolate one rectangle, one square. So their centroid can be added up, and that will be equal to the total figure. So muna siya ang 1. So the left side is the total figure, and the right side are the components or the parts, and then their corresponding centroids. Okay, so for you to be able to understand the concept of the area, so just ignore the moment, the first moment term, because I think that di pa mo makasabot ani nga concept. So the formula for getting the bar x and the bar y, so bar x and bar y the are the distances going towards the centroid of the area. So as seen here in the figure, bar x and then bar y leading to the centroid of the area. So again, since our concept is we're going to add up different parts or several parts, and then their corresponding centroids, so on the right side, so that's why we're going to take up a differential area. So for example, this is our differential area, dA, and then we're going to determine the distance of the centroid of this particular differential area. So let's say we're going to be solving x sub c as the distance of the differential area, and then y sub c will be the centroid of that differential area. So that will be on the right side of the equation as seen here on the third line, as well as the fourth line, y sub c. And these will be your formulas. So take note that the the derivation of this formula started from bar x times the area, and then equal to the summation of, let's say, the different centroids of your areas, di ba? For the several parts and their corresponding centroids. Now, again, since we'll be dealing with irregular shape figures later on, so we cannot exactly say that our figures that we're going to deal with in our problems are polygons, di ba? So as you can see in the figure, so it's an irregular shape object. So more likely we'll be dealing with curves. So we'll be translating your sigma notation into an integral. So this becomes an integral. So the summation translates into the integral symbol sum, summa, and then x sub n will be your x sub c. And again, since the shape is now irregular, the shape is coming from irregular shape figure, so your a sub n becomes the differential area. So that's how the formula was derived. So on the left side, that will be bar x times the total area. So that will be the same for bar y as well. So solving bar x separately, then after solving bar x, then you're going to solve for bar y. Okay, so again, as seen in the figure, the left part is the whole system, referring to the centroid of the material. On the left side is the several parts leading up into the whole component. So as you can see, this is the differential area or the delta area, then the corresponding centroid of this one. So ako lang gidraw ni ganina, so I just draw the differential area on this aspect, but it's actually should be on the right side. All right, so I think since looking on the formula, so as you can see, we still have the area component. So you still need to solve the area of your problem first before solving for the bar x and bar y. Okay, so let's start with this problem. So locate the centroid of the region bounded by x squared equals 8y and x minus 2y plus 8 equals 0. So the graph is already given for us to save time. But again, in your problem solving later on, so you'll be providing the graph from scratch, and of course you'll be providing solutions on how you generated your graph. So again, the graph presented is for us to be able to get to the point of this topic. So para dito madugay. So again, in your problem set later, so you'll be the one creating the graphs, and then of course you will be providing solution for your graph as well. So especially in the exam. So I won't be giving credit to the graphs that will magically appear in your solution. So for example, you have this graph and then you don't have the calculations to back up your graph, so I will not mark it correct. So So in my perspective, I can say that you just copied the graph, diba? Because you already generated the graph immediately without even having evidences to support it. Okay, so again, key notes in determining the graph. So let's try to put the steps in our solution. So first is the graph. So you create the graph, provide solution, and next is you also solve for the points of intersection. So this is the graph. So again, in your case, you have to provide a solution. And then next is you have to provide solution in determining the points of intersection as well. So in this case, the points of intersection is -4 and 2. Then the other one is 8 and then 8. So again, you have to provide solutions for your graph and for your points of intersection. So I think I have already discussed this one in the topic on area, the first topic on area. Okay, so next step is, again, if you try to write the formulas above, so bar x times area is equal to x sub c times the differential area. Then the other one is bar y times area is equal to y sub c times the differential area. So notice that we're going to notice that we're going to use we're going to solve for the area as well, as seen in the formula. So the next step is for you to solve the area of the bounded region. So solve for the area. So again, in solving for the area, so if you have already forgotten how to solve for the area, so again, there are two ways in solving the area. So that will be the vertical strip and then the horizontal strip. So vertical strip is this formula. So y top minus y bottom dx from x1 to x2. And then horizontal strip is from, so that will be x right minus x left dy from y1 to y2. So again, if we're going to check first whether or not we can use the vertical strip or not. And so in this case, we can see that we're going to use the vertical strip because I already drew the vertical strip in this aspect, but I'm going to show you how to determine whether you're going to use vertical strip or not. So if I'm going to place my strip on the right side as well, then let's say I'm going to place it on the leftmost part as well. So the top portion is touching the blue graph. So meaning it's consistent all throughout the area that is bounded by the equations. Now the bottom part of the strip is touching the red graph. So red graph and then red graph. So meaning since it's consistent all throughout, the top portion of the vertical strip is always touching the blue line, and then the bottom part is always touching the red curve. So I can say that anywhere I place my vertical strip, it's always touching the same equations, blue and then red on the bottom part. So meaning I can use the vertical strip in solving for the area. Now, if I'm going to check for the horizontal aspect, so let's say this is I'm going to place one horizontal on the rightmost part, going to place one horizontal in the middle part, and then another green or horizontal strip at the bottom part. So observing the right hand side of the horizontal strip, so it's touching the red curve or the red graph. Now on the left part, so this one is touching the blue side, this one is touching the blue graph, but on the bottom part of the horizontal strip, so it's touching the red graph. So meaning it's not consistent all throughout the distribution of your horizontal strip. So again, the purpose of which why we cannot let your strip be touching the same equation is that upon looking on your equation, so if your right and left are the same equation, so meaning the resulting integral will be 0, di ba? So that's why we don't want that to happen in our process. So meaning in this aspect, you cannot use your horizontal strip because again, the distribution of your horizontal strip, anywhere I place it on the bounded region, is not consistent. So again, the ends of your strip must not must be unique to the other. It's unique, so the right side must be unique on the left side, and it must be consistent all throughout. So the right side will be the red graph, or the blue side will be consistently be the blue graph. So I think you get my point on how you're going to determine which strip you're going to use. So let me erase this part. So in solving for the area, so again, since we'll be utilizing the vertical strip, so area is equal to y top minus y bottom dx. That will be from x1 to x2. So again, the blue line or the blue graph will be your y top. This will be your y top. And again, we'll be isolating it in terms of x. So y equals x something. So this is our y top. And then for the red graph, this will be the equation. And again, we're going to isolate y. So it should, para the equation is in terms of x, y equals x something. So this will be our y bottom. All right, so the area is from y top, that will be x over 2 plus 4, and then minus x squared over 8 dx. So from x sub 1 to x sub 2, so this will be the boundary on the x direction. So that will be from negative 4 going to 8. So again, since you are now allowed to use your calculator, so you can plug this one directly, then get the answer for the area. So as long as you provide this line here in your solution, then you have the answer. So that's correct, or that will be the correct process. But if you're just going to present me with the formula and then the answer magically appeared, so that will be a wrong solution. So not sufficient evidence was presented. So, okay. So in solving the equation in the calculator, so this will be 36 units. Square units. Square units because it's area. So if you're going to ask me how I plug this one in my calculator, so I'm fond of grouping my terms with parentheses. So if you plug it in the calculator, so this will be -4 to 8. And since there's no bracket in the calculator, there's no bracket function. So instead of bracket, I'm going to use parentheses, then parentheses again, x over 2 plus 4, and then minus x squared over 8, then parentheses, and then parentheses again, then dx. So the purpose of why I'm grouping it with many parentheses is that so I can trace my terms when I double check my solution. So I can say that this enclosed parenthesis here is the y top function, and then this enclosed parenthesis here in the second term will be the y bottom. And of course, to be safe with the distribution of the operation signs. Okay, pasin masayop pa, di ba? Because one mistake in declaring the operation will result to a different answer. Okay, so I think the first part is easy since we already know how to solve for the area. So this will be the solution for the area. Okay, so for the next step is we can now solve for bar x. So the third step is solving for bar x. So again, if we try to write the formula, so this will be bar x times the area. So take note that we already solved the area earlier on the second step. So x sub c times the differential area. So take note that our differential area that we have used is the vertical strip. So meaning if you have used the vertical strip on solving for the area, so in solving for bar x, we're going to utilize the vertical strip as well. So meaning you start with the vertical strip, then you end also the problem. So if you're going to solve for bar x and bar y, you will be utilizing the vertical strip all throughout the process of solving the centroid. So from area to bar x to bar y, so you're going to be utilizing the same strip. So how are we going to utilize the vertical strip? So it will be inputted here in the differential area. So more likely we're going to be solving the area twice. But again, so the concept behind here is your differential area is the vertical strip. So meaning if we add up many vertical strips and then their corresponding centroids, that will be the total area and then the corresponding location of the centroid. That's how the concept works. Meaning this line will be translated into bar x times the area. So the integral of x sub c. So again, since we are using vertical strip, So this will become y top minus y bottom dx from x1 to x2. Okay. So if we're going to plug in the values for, so again, it's more like you're going to solve it twice, but on the second part, is that the area is now have a variable of x sub c being multiplied to the area, differential area. So from -4 to 8, and then x sub c, and then again, this will be, so y top is x over 2 plus 4 minus x squared over 8 dx. So notice that all are in terms of x, but for x sub c, it's still the x parameter. I mean x sub c parameter. So we need to make it in terms of x. So again, as per definition, x sub c is the centroid going towards the differential area. So for example, this is our differential area. So going towards the centroid of this differential area, so let's say it's at the center because this one is a rectangular strip. So going towards this distance, going towards the center or the centroid of the differential area, that is x sub c. So how are we going to make it in terms of x? So of course, from 0 going to this distance is x units or x unknown distance, right? And again, the purpose of which is for us to make it in terms of x only, so that it can be consistent with the other parts of the formula. So meaning your x sub c becomes x unknown units feeding towards the center of the differential area. So x times x over 2 plus 4, then minus x squared over 8 dx. So again, your x sub c is the centroid going towards the differential area. And these terms here are your differential area. So x sub c, x sub c. So it's more likely that you're going to solve for the area twice, but on solving for bar x, your area is just multiplied by x sub c. So that's on the right side. So if you already achieve the right side, so of course you're going to copy the left side as well. So bar x, and then so this one is bar x times the area. So bar x, and what we saw from the area on the previous equation or in step number 2 is 36 square units. So you're now ready to solve for bar x. So you're going to solve first the right hand side because the calculator is, I think there's a limitation on the calculator. You cannot solve bar x directly because you'll be having many unknowns in the equation. So solving first the right hand side and then dividing it by 36 for you to be able to get the bar x value. So if you have higher powered calculators, I think you can solve directly bar x. But again, since most of you are having the Casio 991 ES Plus or ES alone or EX, so there's a limitation to that calculator, or for those having the Sharp brand calculator. So again, solving the right side of the equation first. Okay, so this will be 72, then divided by 36. So bar x is equal to 2 units. Okay, so did you get the part here? So do you have questions regarding the process of solving bar x? So none ra. So basin nag-no ra mo nya. Wala mo kasabot. Okay, so since we have solved for bar x, so this is the solution for bar x. So let's try. So on the last part is we're going to solve for your bar y. So solving for bar y. So if you write the formula, that will be bar y times the area is equal to the integral of y sub c times the differential area. So again, since our differential area is the vertical strip, so this translates into bar y times the area. And then again, since we'll be utilizing the same vertical strip, so this is y top minus y bottom dx from x1 to x2. So writing again the formula, so we're going to have negative 4 to 8, then y sub c, and then again our y top is x over 2 plus 4, then minus x squared over 8, then dx. So notice again that all are in terms of x on the right side. So we need to transform y sub c into the corresponding values of x. So let's say again, this is the centroid of your differential area, and this is your y sub c. So again, the distance is in the y direction. So how are we going to make it in terms of x? So earlier, it's easy for us to say that x sub c is equal to x because the direction is already in the x-axis. So we can say your x sub c is just x unknown units because again the direction is already in the x direction or in the x-axis. But for y sub c, the direction is y units. So we need to convert it into in terms of x for us to be able to completely solve the integral equation, because again notice that we are integrating with respect to x. So it must be that your y sub c excuse me. So it must be that your y sub c must be in terms of x for us to be able to integrate the equation. So unsa man na siya? So how are we going to solve for y sub c that in such terms that your y sub c is in terms of x variables? So we're going to excuse me. Okay, so we're going to use the concept of midpoint formula. Okay, so let's say this is the line here. So let's make the vertical strip here into a line. Ako lang ikaw Andrea. So let's say this is the line, and then this is one point here. Then this one is another point here. Then let's say this is the midpoint. This is y sub c. Okay, so according to the midpoint formula, excuse kay pilit kayang one. Okay, so according to the midpoint formula, so the distance between 2 points. So in determining the midpoint between 2 points, so you're going to add up the first point and the last point, and then getting the average or dividing it by 2. So one example of this is, for example, let's make it in the x-axis. So let's have this number line here. So 0, 1, 2, 3, and then 4. So let's say our first point is 1, and then the second point is 4. So the midpoint is, so let's say the distance between 1 and 4 is 3. So the midpoint is 2.5. So this is the midpoint. So in mathematical terms, so how do we solve for the midpoint? Is that again we're going to add up the 2 points, the inner and the outer points, and then dividing it by 2. So meaning this will be x sub m is equal to x1 plus x2 over 2. So you have 1 plus 4 over 2, then that will be 5 over 2, or equal to 2.5. So meaning the midpoint is correct. Diba? So on this particular solution, we're going to be utilizing the midpoint formula. So how do we utilize this in this aspect? So notice that the bottom part is touching the right graph. So meaning this distance here is y bottom. And then this part here going to the top portion is touching the blue graph, or the line is touching the blue graph, and this will be y top. So notice that we are in the y axis. So the midpoint y sub c is this portion here. I mean, this one is y top, this one is y sub c. So again, we're going to use the midpoint formula. So y sub c is equal to y top plus y bottom all over 2. So meaning this translates into, so negative 4, then 8, and then you're going to have y top plus y bottom over 2, and then times x over 2 plus 4 minus x squared over 8 x. So again, since we know the value for y top and y bottom, so the formula translates even further into this line here. So it becomes x plus 2, x over 2 plus 4 plus x squared over 8 all over 2, and then x over 2 plus 4 minus x squared over 8 dx. Then on the left side is you're going to have bar y, then the area is 36 units. Okay, so again, you have to solve first the right hand side of the equation. So most likely I just did it in this manner because for you to be able to understand how you're going to solve for y sub c. But again, you can simplify the equation even further. So as you can see here, y top plus y bottom over 2, then multiplied by y top minus y bottom. So most likely the equation is, so I'm going to write it here on the upper right. So it will look like this one. So y top plus y bottom over 2, and then y top minus y bottom dx. So you can multiply the numerator and then have this term here. So 1/2 and then y top squared minus y bottom squared dx. So that's the easier version, but again, I did it step by step for you to be able to understand how I got y sub c, or the different parts of the equation. So this will be 36, and then the value for the integral, so this is 115.2, and then divided by 36, so bar y is equal to 3.2 units. So that's how you solve bar y. So you can express your answer also in this manner. So bar x, so more likely a coordinate system. Bar x, bar y is equal to 2.0 and then 3 point. So maraga na siya nga pag-present. Alright, so do you have questions or clarifications? So the 3.2. So questions or clarifications? Alright, so I think there's no clarifications. Sige, so question. Ano si Jack? Hello? Murag di ka madungog. Hello? Murag di ko kadungog niya. Ano ba? Di ko kadungog niya. Ako kabawang ano. Okay, sige. Oh, una jud siya ang graph jud. Kay ini ka start sa problem. Marag tagaan naman ni nga Marginig start sa problem kay ang ihatag sa inyo is kanira jud. This line here. So no graph provided, so only the problem. So you have to make everything from scratch. So if we're going to fast forward sa kuan problem set, so muna siya, muna yung problem set. So as you can see, it's purely just words. Na what you siya ilain, walay free graph, walay free drawing. Na you have to understand how to solve the different parts jud. All right. So this is the solution. So moto ang purpose why I'm numbering the steps. So graph, then solve for the area, then solve for bar x, and then solve for bar y. So any more further questions? Okay, so there's none. So let's proceed with the second example. So again, you are given this problem only. So you have to generate first the graph. And again, the graph presented on your screen is just for the sake of discussion, because again, the important part of this topic is solving for the centroid. So again, the first step is for you to graph the equations and then get the points of intersection. So again, provide solution for each of, so provide solution for the graph, provide solution for the points of intersection. Okay, so next is you determine the area. So solving for area. So as you might see, so we are already having the vertical strip. But again, if we try to determine if it can be solved using the horizontal strip, so it can be solved using the horizontal strip also. So again, if I draw vertical strips at the ends, so notice that the top portion is touching the purple line, y equals 4. The bottom part is always touching the red graph. So to check if we can using horizontal strip, so let's place one portion here at the very top, at the middle part as well, and then at the very bottom part. So the right part of the horizontal strip are all touching the red graph, and then the left portion are all touching the same graph as well. That will be x equals 0. So meaning you can solve this one either the vertical strip or the horizontal strip. So let's try to see. So let's solve it using the two methods. So first is, let's utilize first the vertical strip. Then afterwards is we're going to use the horizontal strip. So to see if there's a difference. So y top is y equals 4. This is y top. And then y bottom is the red graph. So meaning if this one is your equation, so isolating y to get y bottom, So y bottom is equals to 2 square root of x. So area is equal to, so again from x1 to x2, y top minus y bottom dx. So again, the limits of integration is from x to x, x1 to x2. So that will be from 0 to 4. And then y top is the line, y equals 4. So that will be 4. And then minus the bottom part, which is the red graph, 2 square root of x. And then dx. Okay, so again, you can use your calculator at this point. So the area is equal to 16 over 3, which is approximately equal to 5.333. So square units. Okay. That will be the solution for the area. Okay, so next is your bar x. So solving for bar x, that will be bar x times area is equal to x sub c times the differential area. So again, we are using the vertical strip, so we're going to have x sub c times y top minus y bottom dx. Then again, since our variable of integration is with respect to x, so if this one is our x sub c, so notice that it's in the line of direction of the x-axis. So this will be x unknown units. So this will translate into bar x times the area is equal to x times y top minus y bottom dx. So plugging in the values even further, so you have x1 to x1 to x2, and then so ako lang i-rewrite balik kay kuwangan. So bar x times the area is equal to 0 to 4, and then x times 4 minus 2 square root of x, and then dx. So bar x times 5.33. Then on the right side, the value of the integral. Then bar x. So excuse. So this will be 6.4 and divided by 5.33. So this will give you 1.2 units. All right, so next is, so this is the solution for bar x. So next is bar y. So solving for bar y. So bar y times area is equal to y sub c times the differential area. So again, y sub c is the midpoint formula because we are in the x-axis parameter. So if this is y sub c, and then again this is the bottom point, this is the upper point. So this will give us the midpoint formula concept. So this is y top plus y bottom all over 2. So if we're going to place our equation, so this becomes from x1 to x2, and then y top plus y bottom all over 2, then y top minus y bottom dx. So combining the numerators, so you can have this one as from 0 to 4, and then you're going to have y top squared minus y bottom squared all over 2 dx. So from 0 to 4, so you're going to have 4 squared, and then minus 2 square root of x squared all over 2 dx. So bar y times 5.33 is equal to this term here. And then you have your bar y. So this is 15.99. Then your bar y is 3 units. Alright, so that will be for the vertical strip. So do you have questions so far? Okay, so far so good. Okay, so let's proceed with so this is the solution there for the bar y. Okay, so let's go to the horizontal strip since we can solve this one using the horizontal strip as well. So again, first is you graph your equations, then provide solutions for both also graph and the points of intersection. So next one is the area. So area is now, so again, since we are now utilizing the horizontal strip, so x right minus x left dy from y1 to y2. So this will be our limits now. So still from 0 to 4. So this is from 0 to 4. And then our x right is the red graph. So this one, isolating x to make it in terms of y. So x equals y something. So this is your x right. So on the left side, it's touching the y-axis, and the equation of which is x equals 0. So this is 1. X left is equal to 0. So notice that if you try to compare the horizontal versus the vertical strip, so let's look at the equation. So y squared over 4, and then minus 0, dy. So notice that the equation for the horizontal strip is only giving you y squared over 4 dy. Diba? Murag simple kay siya compared to your vertical strip. So this will give you the same answer, 16 over 3, or equal to 5.33 square units. Okay, so this is the solution. So next is solving bar x. So bar x times the area is equal to integral of x sub c differential area. So again, since we are now in the horizontal strip aspect, so if we try to break this down, so x sub c and then xr minus xl and dy from y1 to y2. So notice that our variable should be in terms of x. So if this is x sub c, so we cannot directly say that this will be equal to x because again we are integrating with respect to y. So this time we're going to utilize it on the horizontal strip, the midpoint concept. So your x sub c, so if this one is your x left, this one is your x right. So meaning x sub c is equal to x right plus x left all over 2. Diba? So it's now reversed. So earlier in using the vertical strip, when solving for y sub c, we're using the midpoint concept. But for the horizontal strip, so magnabali siya, di ba? So it's being reversed now. So we are utilizing the midpoint concept in the x sub c variable. So this becomes x right plus x left all over 2. So again, this is coming from x sub c. And then x right minus x left dy from y1 to y2. So again, you can further simplify this one by combining the numerator and denominator. I mean, by multiplying the numerator, you're going to have xr squared minus x left squared all over 2 dy. And on the left side, bar x times the area. So bar x times the area is equal to, so from 0 to 4, then y squared over 4 squared minus 0 squared all over 2 dy. So again, notice again that the equation is simplified because we're going to have a zero term here. So this will lead you to 5.33, then equals to, so from 0 to 4, then this becomes y to the power of 4 over 32 dy. But it's an easy integral compared to the vertical strip. So this gives you bar x 5.33. Then the right side is on the same gapon earlier. So 6.4 gapon. And then bar x is 1.2 units. Okay, so this is the solution for the horizontal strip. So lastly is your bar y. So solving for bar y. So bar y times area is equal to y sub c times the differential area. So again, y sub c is already in the y direction since we are utilizing the horizontal strip. So, so y sub c and then x right minus x left dy from y1 to y2. So again, in terms of y dapat, so our y sub c, so since it's already in the y direction, so this will be equal to y unknown units. So this becomes, so from 0 to 4 times y, and then x right is again y squared over 4 minus 0 dy. So we're going to have bar y times 5.33, then integral from 0 to 4. So again, distribute y. Of course, you're going to help your calculator also in solving the equations in a faster pace. So, diba, if you're going to write 0, so you're just adding some some additional information in the calculator. So, irrelevant pa dyan because it's 0. So, try simplifying your equation so that you can help your calculator in solving for the values that you want to get. So, y cubed over 4 and then dy. So 5.33 equals 15.99. Then bar y is equal to 3 units. So the same answers as the given solution using the vertical strip. So this is the solution. So questions or clarifications? Okay, so there's no question. So tip here is that if you want to determine, so for example, you can solve your equations or you can solve the area using or area or centroid using both horizontal and vertical strips. So my tip here is you're going to observe the equations, given equations. So x equals 0 and y equals 4 are easy equations. So the calculator can handle this directly. And of course by you as well in simplifying your equations. So y squared equals 4x is if we try to isolate y, so this one y equals 2 square root of x. And then if we try to isolate it in x aspect, or if we try to isolate x to make it in terms of y, so this becomes x equals y squared over 4. So observing the two equations generated, so you don't want to be dealing with radical expressions. So again, you try to avoid radical expressions as much as possible, but of course, you can still work on the radical expressions, but again, the calculator might have a hard time giving you the values if you're going to plug in radical expressions compared to non-radical terms sa inyong calculator. So that's why if in this problem, if you're going to recreate this problem, So might as well go directly to the horizontal strip. So avoid the vertical strip because it will be dealing with radical expressions. All right, so I think that's it for today if you don't have any further questions. So the problem set is up in the canvas. So if you're going to create your graph, so again, make sure that you're going to provide solutions as well as solutions for your points of intersection. So if you want to use MS Paint, so let's say you have a graphing tablet and you want to create your graphs digitally. So dili siya kanang kuana generated by a Desmos. So dapat kamo nagmano-mano og you are the ones creating the graph on your own. So dili ka tong generated by Desmos or other graphing calculators. So if you want to use MS Paint, so you may use MS Paint, but again, you'll be the one creating your graphs. Or if you want to print the blank X and Y axis for you to be aided in generating your graph, so you may print a blank rectangular coordinate system and then you can plot the points so that you can have a nice graph in your problem sets. All right, so if you don't have any more further questions, so that's it for today. So I won't be holding class this Friday for you to work on your problem sets, and we'll meet again next Wednesday. So that will be on May 5. So we'll be meeting on May 5 and we'll be discussing a new topic, which is volume. Okay, so thank you all very much, and I'll be uploading the recording in Friday siguro. Okay, so thank you all very much, and then see you on next Wednesday.